how's it going? This is just an introduction to fire alarm plan review. I'm going to jump right in. I don't have any of this scripted, so I'm just going to go off the fly on what's required for plan review and try to walk you through the steps. This is just kind of a general video or an introduction to plan review, and I can go further in detail on all the components such as voltage calcs, battery calcs, and stuff like that in subsequent videos, but this one I'll just start with an overview. So the first thing is the International Fire Code, or the IFC, right? And here I have opened the 2021 edition of the IFC and jumped to Chapter 9, which covers fire protection and life safety systems. And more particularly, if you jump down to Section 907, it covers fire alarm and detection systems. So the code path is through the fire code. The fire code will then reference a standard, which is NFPA 72 for fire alarms. And the standard is what dictates how that system should be designed. Whereas the fire code just gives the minimum requirements and more generalization of the systems. So from the fire code, I've just opened up this section 907.1, and more specifically 907.1.2. You can see it says fire alarm shop drawings here. So if I click that section, it brings us to this code snippet that reads, shop drawings for fire alarm systems shall be prepared in accordance with NFPA 72 and submitted for review and approval prior to system installation. Right, so that's our code path to get over to NFPA 72. For this version of the IFC, in the reference standards, I think it's 2019 edition of NFPA 72. So I've jumped over to NFPA link in this tab, and you see I have NFPA 72 right here, the National Fire Alarm and Signaling Code, so I'll jump into that. I'll change the edition just so we're being transparent with the applicable code reference. So I'll go to the 2019 edition. And in NFPA, it gives a bunch of guidance, right, on how these fire alarm systems should be designed. The first thing is Chapter 7. This is what I want to touch on. Minimum required documentation in NFPA 72. So this is what is required at a minimum by the AHJ, or authority having jurisdiction, typically, right? So as a plan reviewer, your job is to review plans that come through to this standard, right? So the fire code is what plan reviewers and AHJs of fire departments will adhere to, but since it jumps to this standard, then you have to apply the minimum required documentation applicable for that system. So in this case, it's 7.2 of NFPA 72 for the 2019 edition, which reads that you need a written narrative providing intent and system description, or a scope of work typically. You need a riser diagram that's kind of a two-dimensional representation of all of the system components and the wiring and the modules, configuration, any interconnection with those systems. If you're interfacing with a sprinkler system, if it has tampers and flow switches, stuff like that. So you need a riser diagram to represent each floor level as well, and the applicable control panels that are associated with that system. So you'll have signaling line circuits, which are initiating devices like your pull stations and your smoke detectors, heat detectors, stuff like that. And then you'll have notification appliance circuits, or NAC circuits, which will be your visual and audible notifications, such as horns and strobes, speaker strobes, strobes in general, just devices like that. So you'll show all of that on your riser diagram. Then number 3, you need a floor plan layout that shows the location of all those devices, the control equipment, supervising station, all of that, with north arrow pointing compass. And then you need a graphic scale, right? You can't do anything if you don't have a scale. You can't determine the spacing requirements if you don't have a scale that's accurate. So that is a key thing to incorporate into your plans. Room use identification. You want to call out any rooms that have specific function. If you want, like restrooms, any exam rooms, elevators, stuff like that. You need to indicate that on each plan set, so that the AHJ and the person who's responsible, the designer as well, indicates every applicable room so that you can design it accordingly to that space and that the use in that occupancy, right? Going down here, we need a sequence of operation, either an input or output matrix or in a narrative form that describes how each functional device operates, right? So if you have a pull station and you say, what happens when I trip that pull station? What does that actuate, right? So you need to indicate, or you need to have a matrix or a narrative that describes every single applicable device in that system and outlines the exact sequence of operation for that device. What's the end result, right? How that is transmitted to monitoring, what devices that actuates, mag locks that are released, any duct detectors that shut off fans, in RTU units or rooftop units or any HVAC equipment, or smoke dampers if you have smoke control, stuff like that. So you need a sequence of operations to indicate all the applicable devices and how they operate. Then jumping down, we need equipment technical data sheets. So that's for every single device and every piece of equipment that you have, right? You need to have data sheets for the batteries that you select. You need to have data sheets for every single smoke detector model, every single notification model, every single control panel, how that wiring is all interfaced. You need, like, just think if even the wiring itself, right? You need wire charts that show and data sheets for those wires. If you have linear heat detectors, we need to see that. If you have flame detectors, any special systems, you need to indicate every single device and have the model so that the plan reviewer can review those devices, the equipment, the data sheets to what function that device is supposed to have, right? And make sure that it is compliant with the fire code and with this standard. Then, so some of these plan sets can be hundreds of pages long, right? If you got a 4-story hospital that has a ton of different devices, ton of different sequencing going on, you're going to have data sheets that are hundreds of pages. And that's just typical, right? You need to show every single model that you've used, every single device, and all the equipment. Jumping down, we need manufacturers' published instructions, including the operation and maintenance instructions. So that's going off of what I just said. I need to show how it all works together and show all the operating voltages, the current, the temperature ratings, all of that for every piece of equipment that you're utilizing, so that the reviewer can review it and it's designed to a certain standard. Jump down to number 7. You need battery capacity and a safety margin on the Calcs where batteries are provided. So if you have a fire alarm control panel or some booster panels that are powering the system, you need to indicate that by showing all the batteries, and you need to elicit calcs or calculations for that, right? To show that the notification appliances are going to activate and stay in alarm for a certain amount of time, based on the size of the batteries, and that in case the power goes out, that you have a secondary power supply capable of supporting that system, so that occupants in the building can get out in time, in a relative amount of time, right? And we have a minimum standard of 24 hours of standby, and typically it's 5 minutes of an alarm. Unless you have a voice evac system, then you need 15 minutes of alarm. So that would be how you size your batteries to the system capacity. Then number 8 is voltage drop calculations for notification appliance circuits, for NAC circuits, right? So you want to make sure that the voltage at the end of the line of the last device on that circuit, on each circuit that you're utilizing, is in the operating voltage of that piece of equipment, so that it operates accordingly to how it's designed to, right? So you need to have voltage drop calcs that indicate that those devices that are installed are going to work, or with beyond a reasonable doubt that they're going to work, right? That you've done your due diligence and said that, to the best of my knowledge, based off of these calcs and the equipment data sheets and everything, all the parties involved, that these systems, since they're life safety systems, they have to work in the event of an emergency. Jumping down on number 9, that you need the mounting height elevation for wall-mounted devices and appliances. So you need to indicate, like this standard shows, and the data sheets will indicate where these devices have to be installed according to the manufacturer's instructions. Then for number 10, where occupant notification is required, minimum sound pressure levels that must be produced by the audible notification appliances in applicable covered areas. So you need to show decibel drop calculations and say that if there is audibility and intelligibility concerns, that those have to be separately accounted for in their own calculations, and show that the wattage of those devices also is adequate for the system. Then the locations of alarm notification appliances, including the Candela ratings for visual alarm notification appliances. So the spacing is based off of the Candela ratings for a bunch of these visual notification devices. So you have to indicate all of that as on the shop drawings as well, on the floor plans. So each device will have an indication of what the Candela is that it's off-putting, so that occupants in the building are able to quickly identify that the alarm is in alarm, basically. Then you need pathway diagrams between the control unit and the shared comms equipment within the protected premises. So you need to show that the wiring is capable of surviving an event and a certain temperature rating for a certain amount of time. So you need to show the pathway is protected, record retention, record maintenance, and a complete record of inspection and testing. So all of this is basically coalesced into NFPA 72 and says this is the minimum required documentation, right? The AHJ has the authority to request more, be less lenient, whatever. But this is strictly what you have to adhere to on the plan review side if you're submitting fire alarm plans in a jurisdiction and having it submitted to the AHJ for approval. So I'll jump over, since we found the code path, the IFC sends you to NFPA. NFPA spells it out pretty explicitly right here, right? Then I'll jump over to a plan set just as an example that I've taken this plan set here and kind of try to get rid of all the indicators of the companies involved in the designer of record and all the parties involved. So I'm not trying to have any copyright issues or any proprietary issues here, but I thought it was a really good plan, a really good fire alarm plan that I had reviewed and wanted to use it kind of as a template for training, basically. So here we have a fire alarm plan that was submitted. I've omitted the technical data sheets here because there was hundreds of pages, but I can talk about that later on. So this is just strictly the shop drawings and the floor plans that were submitted, right? So this is kind of what a plan set would look like, just for reference. You know, if you're new to this world and you're trying to get into plan review and see what it's all about, this is kind of what it would look like, a general representation visually. So here we have a plan set that I've titled a voice evac for medical office building. So it's got a bunch going on here, right? It's a medical office building, which has its own standard, NFPA 99 for medical systems. And then voice evac, because the occupant load is in excess of the thresholds in the International Building Code and the Fire Code that trip having a voice evac system. So we're going to have 15 minutes of alarm for those battery calcs instead of 5, which is typical. So I'll just jump right down and kind of jump back and forth between NFPA and here just to show, kind of give a face to the name, so to speak. So we'll go back to NFPA. The first thing was a written narrative providing the intent and system description, right? So that's a scope of work. So if I go back to Bluebeam, this is the scope of work that they had provided, and this was a written narrative of it, right? So you kind of spell out the requirements for the system. The facility will be equipped with a new fire alarm system in accordance with 2021 IFC. It's a good thing I chose that one then. So it tells you the codes and standards that are being used on this plan. The fire alarm panel shall be addressable. Speaker strobes and strobes shall be white and labeled fire. Speakers shall be set to the volume setting recommended by the manufacturer to be intelligibility and decibel level requirements, right? So I'm not going to read all of this, but they basically spell out exactly what the system entails, what they're doing, what the scope of work is, right? That's what the scope of work is. They're saying, here's what I'm doing, and here's all the applicable technical documentation outlining that work. So the scope of work is that first bullet right there. Then the next one, and I guess I'll just jump around and go number by number here, but the riser diagram. So once you get good at this, you'll figure out a path that you kind of want to take. If you want to look at the scope of work first, you want to look at the floor plans, if you want to jump into the sequence of ops right away, it doesn't really matter, but as long as you touch all those bases, then you'll be good to go. So we'll jump over to the riser diagram, which I guess is on page 3. So here is, I think they split it up. Yeah, so you can see down here they have a detail that calls out an audio riser diagram. And then if I go up to the north a little bit, it says a visual riser diagram, right? So we'll start with the visual. This, again, is that 2D representation of the entire system, of what they're touching, what the scope of work is, right? So over to the left-hand side, it's kind of confusing, right? There's a ton of symbols. If you've never seen it before, you're like, what is even going on here? So the first thing, I'll just break it down, right? Don't get overwhelmed. A lot of these plans, initially when you're starting out, it's pretty overwhelming. You're like, I have no idea what I'm even looking at. There's so many acronyms. So to kind of bring that down, I find it useful to go back to the symbol legend. So every plan set should have a symbol legend that outlines exactly what each symbol represents, and it should be in accordance with, I think it's, what is it, NFPA? It's not the electrical code. Oh, I don't remember what it is off the top of my head. I'll have to get back, but there's a certain standard that it has to be designed to where each symbol has to be represented. I mean, there's some play there too, because you get some designers that get a little creative with their symbols, and as long as it meets the intent of the code, then you have some leeway there. But for all intents and purposes, it should look, in theory, like this type of plan, right? So a lot of the symbols you see will be kind of reused, and they represent the same thing over and over and over. So we've got the FACP, the fire alarm control panel. So here's the symbol legend, right? It says a new fire alarm symbol legend. And it tells you the symbols that are being utilized on these plans, plus the quantity that they're using, and then a description of it and the model number. So you can reference the symbol legend versus the data sheets and see if they're actually using the equipment that they're saying they're using. So if the symbol says a different model number and you go to the data sheets and they don't have that model number, you're like, red flag number one. So that's just a cross check too. But you can see as I go down this list, there's the fire alarm annunciator. They've got a remote power supply. They're calling APS remote power supply. The AES is the communicator or the dialer for the panel. You've got a graphic map or a G map with a symbol, dock box, a surge suppressor or an SS with 120 volt surge suppressor. Then you've got a photoelectric smoke detector, again with the quantities on the right-hand column. A duct detector, kind of has, it shows kind of the sampling tubes at the top of that symbol, which is kind of cool. The remote test station for the duct detector, because duct detectors are really hard to test in the field, so a lot of times they have remote test stations where you can just trip a switch with a key to trigger that circuit and make sure that it works inside that duct. F with a box is a manual pull station, some single input monitor modules, monitor signal module, modular sync module, high power relay modules. There's a bunch of different unique devices that are being utilized, right? Down here we've got a ceiling mounted speaker strobe. So you can see at the bottom it says 2 watts, and then you have a speaker with 115 candela. That's what this 115 with a C is, right? So it's saying that this device is 115 candela. That's the rating that it's outputting, and I'll show you that in NFPA when we get to notification devices as well. Then we have a wall-mounted strobe. So this one looks a little bit different, right? The other one was a speaker strobe. This is just a strobe. So it looks just like that with a 15, which means that candela rating. Then we have a ceiling mounted strobe, which you can see doesn't have the little wall mounts feature, but it still has a C indicating it's ceiling mounted. Then we have a ceiling mounted strobe that's weatherproof. That's what this WP means. So it's ceiling mounted and weatherproof with a 15 candela rating. And then a wall mounted speaker strobe with 2 watts, 110 candela, and it's wall mounted. That's what the W is. And then we have a weatherproof wall-mounted horn strobe. And then at the bottom, we've got water flow switches and tamper switches. So that's what VS and WF is. That's how it integrates with the sprinkler system. Typically, you'll have a sprinkler system installed in a lot of these buildings. So if you have a fire alarm, it has to interface with that because it needs to supervise those valves as well. If a sprinkler head trips and it starts flowing water, you want that to activate your alarm system. That's just a general symbol legend overview, right? So now we can jump back to the riser diagrams that I was mentioning before. That breaks it down a little bit. It makes it a little bit easier to understand. So if you start here on the left-hand side, we'll see that it shows a remote power supply, right? If you remember, the APS was indicating remote power supply. And they've got a bunch of different inputs and outputs for this power supply. And they're saying that there's a 120 volt surge suppressor, that is interfacing with a 120 volt AC dedicated branch circuit. So that's where the power is coming from utility, right? A dedicated branch circuit is coming to the power supply, and the power supply typically would have a transformer that would step down the voltage that is being supplied to these devices, and you'll just have to verify what the working voltage is or the operating voltage is for these devices. But the power is coming from the utility, it comes into the power supply. The power supply then has 2 12-volt DC batteries that are rated for 7 amp hours. Right, so that's a secondary power. So if you lose the utility power that's coming in from this dedicated branch circuit, then you have batteries for backup power, right? So if you lose that power source, then your batteries will trip in and maintain the alarm for those 24 hours of standby and the 15 minutes of alarm, because this is a voice evac system. So going off of that, we've got 4 different outputs, right? 4 different circuits coming off of this power supply that we'll just take a look at one of them, I guess. You can see that it's indicated by N. This little orange N, that's the wire type. So I'll jump back over to the wire chart and we'll take a look and see what that means. So if I go back to the front page, right? So this is an orange N. And this plan, again, did really well. So if we go below the symbol legend, they've got a fire alarm wire legend, right? So they need to indicate every single wire type that's being utilized. So you can verify that the current going through those wires is that those wires are capable of supporting that load. So up here at the top, you can see there's the orange N visual wiring is what they're labeling it as, and it says it's 1 pair of 14 gauge twisted unshielded. So it's just saying, you know, a bunch of different stuff that's jumbled here, but the key takeaway is that it's 14 gauge twisted pair. So it's the gauge of the wire is determining the amount of current that can be put through and operating those devices in accordance with the electrical code, which is under NFPA 70. Right, and there's a lot going on here that I'm trying to just keep more general, but I could jump into going through the conductor property tables in NFPA 70, but I think it's table 8 in NFPA 70 in conductor properties, which will show you the current ratings going through a bunch of different gauge of wire based on if it's shielded or unshielded, stranded, if it has 1 versus 7. That's a whole nother video entirely, but just for posterity, just know that visual wiring is typically 14 gauge, and you can see on the left-hand side the SLC wiring, or the signaling line circuit for initiating devices, is less. It doesn't need to be as thick, right? It doesn't have to carry as much of a current, as much of a load as the notification appliances that are both emitting a audio and a visual notification. So the SLC is 16 gauge wire. Right, so it's smaller wire, even though the gauge is bigger. As your gauge increases, the wire gets smaller, right? So 14 gauge is smaller gauge than the SLC, but it's thicker wire. So just keep that in mind, that you want visual is typically a smaller gauge wire than SLC is, than your signaling line circuits, and that means that it can hold more current. Hopefully that makes sense. So I'm probably just rambling and explaining that, but that's what that means. And then down here too, as I just noticed when I was trying to explain some of the devices that are in the symbol legend, they spell it out right here with the notification. So you can see that they call it out, right? That the C means ceiling mounted, 15 means 15 candela, and the W down here means wattage. Again, they should spell out all of this, so you're not trying to interpret anything. It should tell you everything you need to know about this system and what they're trying to indicate on the plans. Going off of that, there's governing codes here, right? So they've told us that it's a voice evac system, that the building is fully sprinklered, it's a Group B occupancy in accordance with the building code. So the occupancy type is what dictates a lot of the requirements for the alarm. So they're telling us it's a Group B, and that the building is 1 story and the square footage of it is 28,860. And then they tell us the governing codes that this is being under. I think there's actually a discrepancy here. They've chosen the 2018 building code, 2023 National Electrical Code, or NEC, and the 2019 NFPA code. So I think that's okay, except they have a different code that they set up here for the 2021 IFC. So codes and standards, they should tell you what they're designing the system to as well, right? And then we've got a title block on the right. I'm sorry, I'm just jumping all over the place, but the plan on the right, it shows typically what you would see is the company. They would have a site address, a site name, a contact phone number. So I'll just put these in generally so you can kind of see what it looks like in the title block. Then for fire alarms, since it's a life safety system, we oftentimes require a NICET level 3 in fire alarm systems to stamp it, or a professional engineer to stamp it. So this is just like a general representation of what a professional engineer stamp would look like, as well as like another company logo, company names on here. And you could have a bunch of different people listed. If there's revisions, you could have a revision table that shows who did what when, if you had a bunch of corrections on it, right? And you've got a sheet title that shows the name for each sheet of the plan set. As well as up here, you can see the paper says 30 by 42. So that's the size, that's in inches of what this paper would look like when they print it out for inspectors, fire department inspectors to go out and have construction inspections and actually verify that the systems have been installed in accordance with how these approved plans have, how they indicate. So that's kind of the paper size that you would see out in the field is what they're referencing right there. Then we've got a little sheet legend that shows, what each sheet kind of entails and what it represents. So we've got a cover page, which is what we're on, graphic map and notification, first floor, risers and Calcs, panel details, device details, and the graphic map. I'll go back to NFPA to see what we're at. So we saw the riser diagram, and I'll go back again. I don't want to go into too much detail, but here's the visual riser diagram again that tells us, okay, that this is 14 gauge wire, the orange end that we just saw, right? And it's going to a bunch of different visual notification, visual and audio, as you can see, because some of these are speaker strobes, but this is just indicating the visual riser diagram. So a bunch of different visual devices on each circuit with an end-of-line resistor. That's what this little symbol is indicating, that it's an end-of-line. So we've got a bunch of different strobes, horn strobes, and it shows the candela ratings. This one's 75 candela that's ceiling mounted. This one's 15 candela ceiling mounted. We got some different wattages, And then these numbers and letters that are in the parentheses typically indicate the device address. Since this system is addressable, that means that each device that actuates will typically have an address that is listed on the panel itself. So when the fire department responds to an emergency event, they'll see that, oh, this smoke detector on the second floor in room 212 has tripped, right? So there'll be a device that is according to each there will be an address that is indicated for each device, each applicable device, right? So that the fire department can quickly identify where the alarm is coming from, or where, in theory, where the fire started. So that's what all these parentheses are for. It's indicating which circuit it's on and what device number it is and where that is relative to the graphic map as well as on the panel. You can see that there's this system, this riser diagram is also wired in with 14 gauge wire to another power supply, so APS2, which has its own dedicated branch circuit with a surge suppressor, as well as its own batteries that are inside the panel, and 4 more notification appliance circuits, or NAC circuits, coming off of it, right? With a bunch of different devices. These are all new devices. We'll jump down to the the audio riser diagram. So here we have the main fire alarm control panel, indicated with an SLC circuit. And then we've got some wiring going to an annunciator, and the panel has its own batteries, right? 12 volt DC 35 amp hour batteries that are supporting it in the case of an emergency. Then to the left, we have a surge suppressor that also shows a dedicated branch circuit that's powering the panel itself. Then we have the DACT, or the digital alarm communicator transmitter, which interfaces, it's the panel interface to the dialer, or the radio communicator, so that in the event of something happening, what's happening on the panel can be transmitted to a supervising or monitoring company, right? So the AES dialer, or the radio here, has its own battery supply as well, backup battery supply, that can indicate and transmit any readings it gets from the panel to the monitoring company. Because that's another requirement of fire alarm systems, is that you don't want it just to be local, right? If an alarm is going off in the building, you want occupants to get out, but then you also want the fire department to respond in the case of a fire, right? So you need to somehow transmit that notification to the fire department, and we do that by using a radio dialer or a communicator / transmitter. So we transmit the information from the panel reading to a monitoring company, which then interfaces with dispatch of a fire department, and then you can get a responding unit on the way. I don't want to go into all the technical detail, right? There's a bunch in plan review, and these systems are very complicated, and it takes a while to get up and running. But just for a brief overview, here again is the audio riser diagram. So we've got, now you can see that the wiring is different, right? It's blue with a V. So if we jump back to the beginning, we'll go to the wired chart again and see what that means. So this is indicating audio wiring. You can see the blue V here, and that's saying it's 16 gauge twisted pair. So again, right, it's audio. It doesn't require as much as a visual notification would. So it's a higher gauge wire, which means it has less of a diameter than the lower gauge wire, right? So it doesn't have the same current draw that a notification would. And that's typical. Again, so here we have a bunch of wattages that are indicated, again, with candela ratings for a bunch of these audio devices throughout the system. So it's kind of cool that they broke it up, because typically you'll just see that they have one riser diagram, but I like that this company split it up into both audio and visual and showed those separately. From NFPA, the third step is to take a floor plan layout showing all the locations of devices, control equipment, supervising station, and shared comms equipment within each sheet, right? And you need a north arrow compass, a graphic representation of the scale, the room use identified, and any building features that would affect the placement. So let's go back to the plans and see if that's the case. So we'll jump to the next page now, or go back to page 2, which now says, and again, I'll go down here to the sheet title, which says it's the first floor overall, right? So this is now the floor plan. This is what the floor plan would look like. It shows the layout of the building in a two-dimensional representation, and you could have many pages, right? And you could have detail lines, lead lines that show that, hey, this building's too big to indicate on one sheet and make it legible. So sometimes they cut it in half and they'll put a line that you can reference on the next page and say, okay, this is the line that we broke up from the previous page, and now we start here and look at the next half of the building. But in this case, the building was able to be fully encompassed by one sheet, and it's legible. It's able to be legible on the sheet size that they're going to print off. So At the bottom, you can see a detail that indicates what it is, right? It's a fire alarm plan for the first floor overall. And again, going back to our building description, it said that the building was 1 story, right? So that's where we're, another quick check, you're like, okay, it should just be one, in theory, it should be one sheet that's going to cover the single story, right? So that's what we have. We have a single story that's showing the first floor overall right here. And if you're familiar with floor plans, then it should be a no-brainer that some of these symbols represent doors, like these right here. A lot of them represent walls. Thick lines represent some walls. If you have thinner walls, partitions. There's a, here's a restroom just for a quick reference. Sometimes they have indication of what it is. So you have a toilet and you have a sink. Sometimes there'll be other devices like or other equipment like ovens and receptacles, stuff like that. So we'll just a brief overview of what this is. This is a floor plan, right, for a medical office building. On the left, the floor plans are supposed to show from NFPA the north arrow, a scale, the room use, and any building features that would affect device placement, as well as showing all the location of devices and the control equipment. So going back, we have a north arrow here. You can see the little north arrow that's indicating that this direction is north. You have a graphic scale, and we can see a bunch of different devices laid out throughout this plan. We have notification, ceiling mounted notification throughout. You can see that there's 2 different types of wiring being used. We've got V and N, right? And if we go back to the wire chart, what do V and N represent? Well, V, oh, they should have, yeah, okay, so in this case, N is visual and V is audio. I probably would have switched that and made V visual and N audio, but anyway, going back to the plans, we've got visual and audio wire types going to each of these devices, right, that are speaker strobes. And you can see that indicated here where we just have a strobe that would just have a visual wiring going to it, right? And that's all we have is the N type. But if you go to a speaker strobe, then you have V and N because you need audio and visual. So you can trace these wires around. Typically, you try to look for where the panel is or where your power supply starts, because that's where the circuits are coming off of, right? If we go back to a riser diagram, the riser diagram starts with the power supplies, right? It says there's 4 different outputs and 4 different circuits coming off that are being powered from that power supply. So if you can locate where the power supply is on the plans, that's where you typically would start your circuit. So here we go. If I zoom in on this little location, you can see APS 1 and 2, which are the 2 power supplies that were represented on the riser diagram. And you can see that the wiring starts coming off of them and they start going to devices, right? And you can see that indicated by the addressing on this. So this speaker strobe here, if you can see my cursor, in the parentheses has 1-01-01. Then if you come down, it's 1-01-02, right? So it's chronological. This one should be 1-01-03. So there you go. So you can trace it by number and verify that the number of devices shown is equivalent to what is depicted on the riser diagram. So it's kind of it's cumbersome and time consuming, but if you wanted to verify every single device, then you can go around and do that. I'll try to keep it more general going forward because, again, this is just an introduction. But if you want, I can go through each specific required documentation bullet point here thoroughly and explain how to go about doing each one individually in a lot more detail if you want. So just let me know in the comments. But so that's the floor plan layout, right? It shows all the devices. It should indicate the spacing. I won't go over the spacing right now. I'll probably do that in another video. I can go over notification spacing if you want, SLC spacing, so smoke detector spacing, notification spacing per the occupancy, and the sequencing for elevators with smokes and heat detectors and all that. But just to keep it more general, we'll jump back to NFPA 72. The next minimum required documentation to have, is the sequence of operation. All right, so I'll go back to the plan set and see where that is. You can see that this is the sequence of operations. So again, it shows all the system inputs and all the system outputs that the system has, right? So on the left-hand side, it's kind of cool functionally how this works. So you've got trouble, supervisory, and alarm inputs, and then on the top you've got system outputs. You've got control unit annunciation and fire alarm notification. Um, so we'll just start with the alarm section here. If we have manual pull stations, smoke detectors, general smoke detectors, and sprinkler system water flow, right? So those three things are inputs 2, 3, and 4. Those, if you go horizontally across to these columns now indicate what is output from those inputs. So if you trip a pull station, what does that do? You can go over and you can see these dots that are indicated across. The dots are what is functionally happening as an output, right? So once you trip a pull station, it sends a fire alarm panel, actuates the common alarm signal indicator on the panel itself, and actuates audible alarm signal. Then if you keep going across this row to this next column, it sends a display change of status on the fire alarm control panel. And then it displays a change of status on the fire alarm annunciator panel. And keep going across, right? It actuates the interior audible evac signals. So you've got temporal 3 and evac message because it's a voice evac. Then it actuates the interior visual evac signals and actuates the exterior general alarm horn strobe. And then it transmits the alarm signal to a supervising station. So that's what pull stations would do. You can look below. The smoke detectors are very similar. Right? The smoke detectors also have dots indicating what the output is of those functions. And then if you go down the sprinkler system water flow, you can see the water flow is almost identical, right? It would change the status on the panel. It would, on the panel and the annunciator, the remote annunciator panel, it would send an audible alarm signal at the panel, and it would activate the horns and strobes and all notification devices internally inside the building as well as externally that says, okay, something's going off, we're in alarm now, and we're going to activate the system, right? But then water flow also, if you can see here, this dot, it transmits a water flow signal to the supervising station and says, hey, we're flowing water in this building, get the fire department over here, figure out what's going on. As well as this last dot that says it actuates the outside horn strobe that's above the FDC. And the FDC is the fire department connection, right? So buildings are required, if they have a sprinkler system, to have a fire department connection or an FDC that is outside the building that the fire department can roll up to and hook up their hose lines to service the sprinkler system inside the building, or standpipes that are in stairwells if you have a high rise. But once water flow activates, you want to know that water flow is going off in the building, opposed to a smoke detector, right? If, say, a pull station goes off, somebody trips it for whatever reason, or you burn popcorn in a microwave and it trips a smoke detector, you want to know that that's different than if you have water flowing from a sprinkler head, right? If you have water flow from a sprinkler head, it's probably an indicator that you have an event, a fire event occurring, opposed to an ancillary alarm activation that could be a result of something of just human error, right? Granted that you could also break a sprinkler head if you have maintenance personnel that are servicing something, and it's happened before. You can flood systems, whatnot, but generally, if a sprinkler is going off and there's water flow, then you probably have a bigger issue than if a sprinkler head or a smoke detector is activated. So that's why you want a specific indicator that water is flowing in the building. So when water flow goes off, you want the fire alarm to indicate that is happening as well. So that's why it's different than just also activating the general alarm. And I'll just keep it simple again, but the next piece would be the equipment technical data sheets. I've omitted that from these plans as I indicated. I could show it in a later video, but typically they just be appended to the rest of this document, and it would be like 300 pages long of just data sheets for every single device, right? It's just the manufacturer's published data sheet that says, hey, this is the device, here's all the technical information and jargon about it, so that you can reference it and jump back and forth between the plan set and make sure that device or that equipment is going to function as intended, that it's the right equipment and listed to whatever your needs are, blah, blah, blah. So I just don't have it here, but you would need that in the plan set, as well as the manufacturer's published instructions. If there's any specific things that are outlined from the manufacturer for the said device or equipment, you need to indicate that. But now we'll jump into number 7, which is the battery capacity and the safety margin calcs, where batteries are provided. Again, I'll probably make a separate video about both the battery capacity as well as the voltage drop calcs, just because they're more nuanced as well. But in this case, we do have batteries for the system, as if you remember seeing them in the power supplies. You can see a battery here, batteries up there, as well as in the panel down on the audio riser diagram. So we do have batteries, so that means that we need battery calcs, right? You need to show that the system is going to function as intended and that it's going to work, that your batteries aren't undersized for the system, that if you lose your main utility power, that the system, only half the system will work, right? Like it's a life safety system, so you have to verify that the batteries are adequate and they will support the capacity required for that. So here's a detail that shows battery calcs for the first power supply, right? Again, I'll go into this, I'll probably do an offshoot, which is going to go into more detail, but here's the battery calcs right here. So it's showing us that for the remote power supply number 1, we are required to have 24 hours of standby, you can see from this first row, as well as 15 minutes of alarm because it's voice evac, right? Then we have an indication of the alarm current that's in each NAC circuit, right? So we have 4 notification appliance circuits, right? And let me go back to power supply number 1. You can see there's 4 output 1, 2, 3, and 4, right? So that means you have 4 notification appliance circuits or 4 NAC circuits. And that's what's reflected here in the calcs. You've got 4 NAC circuits, right, that have different amperage associated with each of those circuits. So that's one quick check, is that you want to make sure that you have enough, that the NAC circuits are adequately identified on the calcs, right? That you're not omitting certain devices or certain circuits, and that everything is being accounted for in the calculations. So going down, we've got some standby amperage for auxiliary standby and auxiliary loading. So you would sum these columns because you have standby milliamps as well as alarm milliamps. So you have to indicate all the amperage that's being drawn from each circuit on each NAC circuit, and kind of total that, what the panel and what these power supplies are gonna, what load they're gonna see, right? So at the bottom, you can say that there's 82 total milliamp standby, as well as 1,733 milliamps of alarm, right? That's what in theory could happen, that the operating voltage of these devices is this value. Then you want to take those totals for each standby and alarm, and you want to take the standby, multiply it by the required standby hours, and then you want to take the alarm milliamperage and multiply that by the total required alarm in minutes, right? So we had 82 milliamps that we're going to multiply by 24 hours because we were required to have 24 hours of standby. So 82 times 24 gives us the 1,968 down here, right? And then you want to take the 1,733 milliamp alarm load and multiply that by the 15 minutes of alarm that's required up here. So that gives us 433.250, and we've adjusted it here. We divided by 60 just to get it into hours, because it was referenced in minutes, right? But you want to take the 15 minutes, divide by 60 to get that value into hours, and then multiply by the current, so that we're dealing with the same units on these values. Because then you want to add them together. So we add the total standby that we just calced, as well as the total alarm. So that 1,968 plus 433.2, you add those together, you get 2,401.2. And then you want to derate those batteries. So there's a safety factor built into these battery calcs that says, hey, at the end of the life of this system, the batteries aren't going to be as efficient as they are now, right? They're going to lose efficiency as they age, because the cathode and the anode are going to keep doing what they do with the electrolyte, and they're going to slowly lose mass, basically, right? You're going to lose mass from the cathode that's going to go to the anode over time. And so that efficiency is going to go down in that battery. So we account for that by saying that, hey, let's add a 25% safety factor onto this, such that in the event that it is end of life, that we've oversized the system such that it can withstand any unforeseen circumstances, in theory. So you want to take that total current capacity that we just calculated, and you want to multiply that value by 25% safety factor, derating factor. And that gives us 3001.563. And that, I think this is in milliamps. So if we divide that value by 1,000, in milliamps to get amps. That leaves us with 3 amps, which is what they calculated here. Calculated battery amp hours, right, is 3. So we need at least 3 amps of batteries in order to adequately support this loading. So that's what we've done. You can see at the bottom, if this is the required capacity, then the proposed batteries that they want to submit they want to have 2 7.2 amp hour batteries, right? So that is greater than the load, than the required amp hours, and so we're good to go. If it's less, there's a problem that hey, these batteries aren't going to support that load, and you need to you need to up those batteries and increase the capacity. So that's just a quick synopsis of battery calcs. I'll go into that in more detail, but that's step 7 from NFPA 72. Then if we go to the voltage drop calcs for notification appliance circuits, then we can jump back to that's number 8 from NFPA 72, right, for minimum required documentation. So we'll go back into the plan set and go up a little bit, and you can see that this is actually the voltage drop calcs that these people have provided, where it says that there's a bunch of different stuff going on here. But basically, they're saying, hey, here's the resistance tables from the electrical code, the conductor property tables that say, if you're using 12 gauge wire, 14 gauge wire, 16 gauge wire, you have different impedance values, which are given here, right? So you're going to lose a certain amount of voltage over the length of wire, right? And the impedance, the wire itself is going to contribute to some of those losses. So they have different impedance values based on the size of that. And you can see that it kind of makes intuitive sense. I mean, electricity is very complicated, but if you can think of it kind of like how water flows, the smaller the lumen of the pipe, the more, or I guess the smaller the diameter, of the pipe, the more friction you're going to have, right? If you increase that diameter, there's less of the wall friction that's going to affect the rest of the flow. So it's kind of the same intuitively for electrical circuits. So if you have a bigger wire gauge, you have a smaller constricted wire, that means that it's going to take a lot more force to get that electricity to move through that wire, and you're going to have higher losses, right? So the impedance is going to be greater for a greater gauge of wire. But if you decrease the gauge of the wire, you increase that diameter of the wire, which means you're going to have less losses. It's going to be easier to flow through that. So that's what was indicated here. They indicate that there's a source voltage. So the source voltage is the load that's being applied to the circuit, and that's your input value. So it's typically, I think it's 85% of the operating voltage. So they've calculated it here to be, you can see at the top, the source voltage is 19.7 minus total current times 0.7 volts due to power supply load factor. So they calculated it as 19.357. So that's their input voltage that's going into this circuit. You start with that value, and you want to, I think they've done a point to point, it looks like, instead of a lump sum voltage method. But there's 2 different methods you can do for voltage drop. And again, I'll touch base in a different video for voltage drop specifically, but they indicate a bunch of different devices that are used in this circuit. You can see the current ratings for each device listed here. They're all different. You have to indicate the wire distance between each device, right, and the total distance for that entire circuit. So you've got 32 feet from the power supply to the first device, and you can see the total distance is 32. Then you jump to the next device, you're adding 21 feet. So there's 21 feet between the first device and the second device, which gives you a total of 53 feet from the power supply, right? And you just keep doing that. So that's what this total distance is indicating. And then they're saying that the wire gauge, the gauge is 14 gauge for that entire circuit. So we know the impedance value. And then the resistance as that circuit keeps increasing is indicated for each device. So this is point to point again, but you can do a lump sum where you calculate the whole circuit, and it's more conservative. And I think in the 2025 version of NFPA 72, they've said that it's the preferable value is actually using the voltage or the lump sum method, because it's more conservative than doing the point to point. But regardless, they're still allowed to do the point to point, and then you can determine from that input voltage what the end of line voltage will be at your last device. And you can see that it should make sense that the voltage is going to drop, right, as you keep increasing devices that you're utilizing, as well as increasing the distance away from the power supply. So at the end, the voltage is 18.2364, where it started at 19.357. So that makes sense. You're like, okay, 21 devices down the line, the voltage is going to be this much, right? And it just has to be above a certain value, which is 16 volts, which I've indicated at the top that the minimum UL rated appliance voltage is 16 volts for these systems. So as long as they're above 16 volts at the end of their line, then they're good to go. And there's a bunch of different voltage tables, again, because you need a separate voltage drop calc for every single notification appliance circuit, right? And if I go over to the left again, we had 4 NAC circuits from this power supply. The power supply above it also has 4 NAC circuits. So we need a total of 8, right? We need 8 different voltage drop calcs. And you can see that there's 1, 2, I don't know what that bottom one is. 1, 2, 3. This is a separate one. 4, 5, 6, 7. I think there's a second one that's embedded in here. Yeah, 7 and 8, right? So these ones both had just weatherproof devices, but there are 8 separate voltage drop calcs, and entirely right here. And we've got two separate remote power supply battery calcs, right? We had one power supply here, one power supply here. So we've got one battery calc here, one battery calc here to represent those. Then if you drop down, we've got another panel, fire alarm control panel. So we need another battery calc just for that, as well as then you have decibel loss calcs, which is I think the next piece in the minimum required documentation. No, it looks like it's mounting height elevation for wall-mounted devices and appliances. So if we jump back over to the plans, that's the next thing that you're required to have for per NFPA 72. So if we jump to the main page, the cover page, you can see that they've indicated the device mounting guidelines right here. So they're showing, hey, based off the ceiling height and the walls, this is where these devices need to be installed, right? And it just kind of spells out the height requirements. And so when the construction inspectors go out from a fire department or in general, a third party, whatever, if you're doing acceptance testing of the system, then you can verify that these devices are installed according to the manufacturer's instructions and that they're going to function and they're installed according to how they're designed to work, right? So they need to be installed in certain locations in order to function as intended. So they have those device mounting guidelines here, and you can read it for yourself, the different heights of different devices and the requirements, such forth. Then going back to the minimum required documents, here we go. It's number 10 that outlines the decibel loss. You've got where occupant notification is required, the minimum sound pressure levels must be produced by the audible notification appliances in applicable covered areas. So they've indicated a decibel drop calc. Let me find it again. If I zoom in, they've got a decibel drop calc or decibel loss calcs here that show 4 different circuits from the amplifier that have different wattage that they're drawing, total distance that it is, and the total decibel loss on each of those. And they're within the requirements for decibel loss. I think electrically in the 2025 edition, it says you can't have more than 1 decibel loss for electrical circuits and not more than 3 decibel loss for NAC circuits typically. So these decibel losses are well under 1 and 3. So they're good there. Just spot checking this, right? Then the location of alarm notification appliances, including candela ratings for visual alarm notification appliances. I think we already covered that because they showed all of the locations on the floor plans of these visual notification devices, as well as the candela ratings are listed, and the wattage and the addresses are all listed on the floor plans themselves with the wire types. So they've got that. And then pathway diagrams between the control unit and the shared comms equipment within the protected premises. So we have the pathway diagrams because it's the wire type that's indicated. Right? It says that these are the types of twisted pair, unshielded wiring that we're going to utilize and what type of plenum rating it is. So they have the pathway represented. And yeah, so this is just a quick synopsis, I guess, of what plan review entails, specifically for fire alarms. You can see, and actually let me just touch on one last thing. They indicate the acoustically distinguishable spaces, right? So like it said, the voltage drop, or the decibel losses, it had where occupant notification is required, the minimum sound pressure levels must be produced by the audible notification appliances in applicable covered areas. So they indicate that what those areas are, and how they're acoustically distinguishable, right? So you need to have a certain level of a certain decibel limit within certain spaces, and that's kind of spelled out here. That says that they're using public mode audible notification, and these are the room uses. Each row is indicating where it is. So you've got corridors. They're expected to have 54 decibels, and the goal is to have 15 decibels above that ambient wherever they are, except for small rooms like elevators, elevator cabs, and restrooms. Right, you don't want it to be so loud that the people in there can't even function. So there's some leeway there, but typically you want to have 15 decibels above ambient, and that's what this is showing, that in each acoustically distinguishable space that they're intending to have 15 decibels above that ambient value. So you can just read it for yourself, that they have a bunch of different types of room uses and what the expected ambient conditions are in those rooms, and then what the goal decibel is at the end of tripping the alarm, and what those values are expected to be read as. So again, there was a lot of information thrown at you in a short amount of time, but this is typically, if you want to get into plan review or trying to get better at it, whatever, this is kind of a nuanced approach, right? This is what it looks like. There's a bunch of different factors going into it, and just stay consistent with the codes. Find the code path, use the code path to start out, and then you can kind of build a checklist like, hey, this is the minimum required documentation. It's spelled out in the code. If you have problems, this is what you reference. Send it back to the designer of record or whatever, and say, hey, you need to send me your sequence of operations, or you need to send me the battery calcs, or something's wrong and you need to correct it, right? The calcs aren't adding up, blah, blah, blah. But it's just a starting point, a general starting point, that this is plan review for fire alarms, and this is kind of what it looks like. So let me know what else you want to see. I can, again, go into further detail for both the battery calcs as well as the voltage drop calcs. And then I can do a spacing on the floor plans themselves for each of these devices and kind of walk you through that, as well as the duct detectors, monitor modules, how that interfaces with the sprinkler system, dampers, mag locks for doors, any smoke control stuff, and then elevator emergency recall and smoke detectors in that, shunt tripping in elevators if you have a sprinkler system, sprinklers in the elevator pits. And yeah, so hopefully this is a good synopsis, and just let me know what you think. Thanks a lot.